Okay, good morning. Thanks, Bill, for the introduction. My name is Niall. I'm the technical lead here in Microsoft Ireland. Me and my team we work with some of our large customers on all sorts of technologies, but we've had the pleasure of working on a few IoT projects, and I wanted to share with you today just some of the technology choices you're going to have to think about as you think about IoT projects, and some of the learnings that we've had. So before I get into the technology too detailed, let me just talk about, at a high level, some of the components of an IoT solution. I think this is really important because one of the learnings we have is that, IoT solutions can be quite complex. There's a lot of stuff going on, a lot of data being moved from one place to another. So you need to think about all of those components. Things like device management and control and network that Adrian talked about. You're going to have to think about analytics on the edge as well, as Mo discussed. How you ingest data is going to be really important. We're assuming when we talk about IoT that we're talking about a lot of data as well. That presents some challenges that you might not be used to when you're thinking about application architecture and solution architecture. As that data comes through, we want to analyze it. We want to analyze the stream of data. We don't just want to store it and look back at that data later on. We might want to do some real-time or near real-time analytics on that data, whether that's on the edge or in the cloud. It doesn't really matter, but we need different kind of capability to do that. So it's another consideration. Obviously, we have the traditional cold path in analytics. In other words, let's store that data. We'll do that as batches. We'll batch process that data and we'll look back at it. But again, we're talking about, in a lot of cases, we're talking about significant amounts of data. And you may be pulling data through from IoT devices, but also pulling data in from internal line of business systems and databases so that you can cross-reference and analyze. So there's a business intelligence element to that as well. And more importantly then, or what's becoming more important now is then what do we do with that data? Can we make decisions on that data? Can we then feed those decisions back down to the edge so decisions can be made in real time? And that's where machine learning, as Mo discussed in detail earlier on, comes in. We also see a lot of use cases where we want to integrate then into the back end with line of business systems. For example, if service engineers need to be dispatched in a manufacturing scenario where there's a fault condition, or if we're in a preventative maintenance scenario where we're trying to predict service schedules, then we may actually proactively send service engineers out. So we see a lot of customers integrating the learnings from the data into line of business systems. The reason this is so important is you need to be very clear from the outset. You could say this about any project, but in particular because IoT projects can be so complex, you need to think about your business value and your business case. You need to be very clear on the value and how you're going to monetize the data and how you're going to cover the cost and get a return from the cost of deploying an IoT solution. With all of the technology we have nowadays, it's relatively easy to put together an IoT solution, but productionizing that and making sure there's a return on investment from that is the key thing. Whether that's a completely new product, whether it's operational efficiency or how you engage with customers, that's a really important point to think about upfront. I do see customers that are, go back to Bill's Andrex example earlier on, that are putting out smart technology, but they're not actually charging customers for it. They can't pass the cost of that on to customers. So they need to think about business models to cover the cost. So let's think about that from an architectural point of view. This is one of the first things that we see customers challenged with when it comes to IoT solutions. Your traditional on-premise architectures where you've got a monolithic architecture, where everything is built to be robust, you're designing it to avoid failures, etc. Servers are, kind of unique in terms of all the components that are deployed, etc., etc. That's traditional on-premise infrastructure simply won't work when it comes to IoT. It's one of the great applications of cloud because it really forces people to think about decomposed, distributed systems, high volume, high throughput, designed for failure, looking at mean time to resolution rather than how to avoid failures and assuming failure and stuff like that. So it's a really good kind of architectural concept. It's not specific to the cloud, the Lambda architecture, but that's really where you need to be thinking when you think about IoT solutions. Now, that's easy to say, but actually for a lot of organizations, that's a massive cultural shift within their organization. So obviously partners like Kainos, et cetera, are geared up to work this way, but culturally within your organization, it's a shift from, like I say, a design to avoid to a design for failure mentality. And that's really important. We'll talk about security later on as well. That's another mindset shift that you need to think about, which is to assume breach as opposed to try and protect and avoid breach. So when we think about a reference architecture for IoT, and this is a very simple version of it, there are a number of components that are really important. And this is a Lambda-based architecture, which means we're doing stream processing and batch processing in a very disconnected way. So we're thinking about separation of concerns. Each component in this architecture is responsible for doing one thing and one thing only. So if you take it from the left, we think about the things, which is the T. We think about the devices themselves. We think about how we provision those devices. That's really important in an IoT scenario. You're assuming there are many devices. So bulk provisioning devices is really important. So we're thinking about edge devices as well. So you may have edge gateways that take the data from the IoT devices, do something with that data, maybe some analytics, or anonymize the data and then send data to a cloud gateway. And that cloud gateway needs to be able to handle significant amounts of data. So it needs to be primed for streaming data, not necessarily for storing data or dealing with transactions. As we come beyond that and get into the cloud, we're into the insights piece, and we'll typically have two paths that we think about. We'll have a warm path and a slow, a warm path and a cold path, or a fast path and a slow path. The fast path is really about making decisions in real time or near real time. Again, the technology choices around that are important. And then the slow path is around batch processing that data and pushing it into maybe a traditional data store that you will be used to, which we can then use as data sources for machine learning or for business intelligence. And then we're into obviously the reporting side of it. On the stream processing side, we will store the data in what we call a warm path store, and we'll analyze that data in real time. And typically we're doing aggregations. Example I always go back to is the sound monitoring we did for Croke Park when we were looking at concerts and regulations around decibel levels. There's no point in looking at spikes. A boom will cause an 80, 90 decibel hit. The regulation says that it can't go over 75 over any 15-minute period. So what we need to do is we need to aggregate that data. We call that a sliding window, where we aggregate that data over 15 minutes. And we make sure that it doesn't go over 75, or if it does, that we send an alert back down to those devices. And that's an interesting point as well when we think about architecture. That communication from, you'll notice the arrows there, from the edge gateways, cloud gateway out to the edge and out to the devices, needs to be two-way. It needs to be a two-way communication so that you can provision and decommission, but also send messages back down. So when we think about message ingestion, really you need to think about the amount of data that you're bringing through. If it's significant, then you're thinking about tools like Kafka, you're thinking about event hubs, and you think about IoT hub. There are others, and there are many ways of doing data ingestion. I mean, you could stick a REST API out there in a web application, but it's not going to be primed for the high volume ingestion that we're talking about. And so Azure Event Hubs is a managed service within Azure. Kafka on HD Insight. HD Insight is a kind of a Hadoop-based file system with a number of different stream processing engines sitting on top of it, an analytics engine sitting on top of it, Kafka being one. And then Azure IoT Hub. My recommendation for IoT scenarios is that you go with Azure IoT Hub. Azure IoT Hub is, in fact, Azure Event Hubs, with a whole lot of new capability on top of it. You can go for Kafka, obviously, and sometimes you'll make decisions based on capability within your organization, skills, and so on. And that's fine. But it is worth looking at just the extra capability that IoT Hub gives you. First of all, it's a managed service, so you're not managing infrastructure and creating clusters and so on. But also, it's primed for IoT scenarios. So it will support MQTT, it will support device management, so we can give every single device that connects an identity. It will manage the security and the handshake between those two using certificates. It will allow us to provision devices. So it really is more than just the ingestion. It also comes with the device capability. But because it uses event hubs underneath, it's well capable of managing millions of data points a second. So it's really the way to go when you think about IoT scenarios. It is a managed service. There's always this concept of lock-in when you use a managed service. Obviously, you can go and build your own infrastructure in Azure and manage all of that yourself for your ingestion. But it would be, in this case, I think, a little bit crazy when you've got something like IoT Hub, which doesn't really lock your data in at all. It's really just streaming that data through to sinks that you decide, and we'll talk about that in a second. So when it comes to stream processing, you have a lot of options. We have a kind of native Azure capability called Stream Analytics, really easy to use, really simple to use. So it's a really good way of taking data from your IoT Hub, doing some aggregation on it, and sending the aggregation results somewhere to do something, whether it's a message queue to trigger an alert, or off to a Cosmos DB or SQL or whatever database to store the data. Really simple to use. Has some limitations, which I'll talk about in a minute. We've got HD Insight with Spark Streaming. Again, I managed kind of a Hadoop cluster, Hadoop file system with different analytics engines on top of it. So we've got Spark built into that. My favorite is Databricks, and we have Apache Spark built into Azure Databricks, so it's a complete Databricks environment managed for you. It just means you can use all of the standard Databricks libraries, install new libraries, but it's a managed service, so you're not into managing infrastructure in any way. Azure Functions, App Service, Web Jobs, and Apache Kafka again with the Streams API. A lot of different options there. If we look at them, there's a bit of a I chart this slide. I will share these slides so that you have them and have all the links embedded in them. But this is a good comparison of the different options. Again, you'll see programmability is an important one if you're thinking about skills and capability within your organization. You'll see Azure Stream Analytics is quite limited when you compare it to the likes of HD Insight with Spark, or indeed Spark and Azure Databricks. That's why my preference would be Azure Databricks. One thing that is interesting about Stream Analytics is that you can build a Stream Analytics query that essentially runs your aggregations in real time over the stream of data that comes through, and you can then deploy that Stream Analytics job down to the edge device. So if that's a relatively standard kind of aggregation query, like the example I used earlier on with Croke Park, where you just want to know if the average window over 15 minutes has gone over a particular spike, it might be better to push that down onto the edge. Otherwise, as you're bringing that, and you can use a combination of these, by the way. You can use Stream Analytics. IoT Hub will partition the data, so it will send the data to Stream Analytics. It will also send it to Azure Databricks if that's what you want. And so you can use a combination. So you could use Stream Analytics for doing the simple aggregations, push it down to the edge. And then Azure Databricks for doing a lot more of the complex kind of data analytics in the cloud. Also, I like the programmability options. I like to write in Python. I like to switch to SQL. There's no SQL there, but I like to switch to SQL syntax when I want to, because that's my background. And then I can do a lot of the machine learning capability in Databricks as well. So when we overlay some of those options onto the reference architecture, this is what we see. I didn't mention Azure Sphere. I'll come to that in a little while. But IoT Hub, device provisioning service, allows you to automatically provision device, push configurations down to those devices, push certificates down to devices, and make sure everything is secured and the handshake to the cloud is secure. IoT Hub, I discussed, that's your cloud gateway. That's managing ingestion. It's allowing you to monitor devices, turn devices on, turn them off, etc. Databricks then is our piece that I would be recommending for the stream processing, maybe with some stream analytics, Azure Stream Analytics built into that as well for different use cases. I then push my data usually into a Cosmos DB. You could use a kind of a data warehouse there, like Azure SQL Data Warehouse or Synapse, as we're calling it now. And then you're into streaming that data out into Power BI using Azure AD as your kind of authentication and user management capability. You can stream data live from Databricks into Power BI portal. It's quite powerful if you want to get a very quick Power BI view of the real-time data. That's possible as well. Or you can point Power BI at your cold store to analyze the data as you normally would. On the other end, then, when it comes to business integration, Logic Apps within Azure, I mean, you can do this any way you want, but Logic Apps allows you to build workflows to integrate data into different systems quite neatly. And we'll talk about machine learning separately. Just a real quick point on availability. It's something that I get asked a lot, what's the availability of Azure? It's an impossible question to answer. And the reason for that is that the SLAs are at a service level. That's really important because it means you can build whatever uptime you want. If you want 4 nines, you can build that because you can put multiple services together. Something to be aware of, though, is that there are SLAs. So IoT Hub 99.9% means that worst case scenario, you're going to be down 48 minutes a month. This is something Microsoft are was very open about. You need to design for that. And that's where the Lambda architecture will come in. You also need to think about composite SLAs. So in other words, if multiple components go down at different times, that means your downtime potentially can increase if they're tightly coupled, like in a traditional architecture. So we see a lot of customers lifting and shifting traditional architectures into the cloud. That can be a problem. With Lambda-based architectures, you don't have that because everything's decoupled. As long as you think about things like retry policies on the edge, device caching, so that if for some reason we can't connect to IoT Hub because it's within that 48 minutes, that it will just continue on. The stream analytics, if it goes down, Azure Databricks, it'll pick up where it's left off the last time. But it is an important consideration, and I have some links in there when you're thinking about IoT and thinking about high availability and disaster recovery. Security considerations are really important. You need end-to-end security. We've built a thing called Azure Security Center in Azure. We have updated that with IoT capability, so that will actually do threat prevention. So it will, in other words, it will recommend configuration scenarios to you to increase security. And it will also do detection. So it will use machine learning to actually look at data on the device. This does require an agent on the device then to say, is there something going on? Is there a man in the middle attack? Has that IoT device been taken over and that type of stuff? Azure Sphere is a new technology that embeds encryption and embeds our BitLocker encryption into a new OS. It's a Linux-based OS, and we're working with hardware partners to embed that OS into microcontrollers. And that's really interesting because it's low cost encryption, and it just means if devices with microcontrollers in them are compromised, that people can't get at the data sources and do man-in-the-middle attacks. And obviously all transport is encrypted via TLS and SSL. On machine learning, there are, again, loads of different ways you can do machine learning. You can create machine learning VMs in Azure to do your modeling. You can do it in Databricks. There's a lot of ML capability in Databricks as well. I would strongly recommend you look at Azure Machine Learning, something Mo said earlier on when you're thinking about pipelines, how you get new models, new data, train models, move those models down to the edge or into the cloud, and how you manage that whole pipeline and movement of machine learning models is really important. It's not proprietary to Microsoft in that you can use your normal Jupyter notebooks. It integrates really well with Databricks so that you can do all of your coding in Databricks and then tell Databricks to use AutoML, for example, to take that data and come up with an automatic machine learning model. It's really, really powerful stuff. If you know anything about machine learning, you'll know that working with the data, getting the data right, doing the feature engineering is probably the biggest piece of work. But once you've done that, let's say in Databricks, you can give it to the AutoML engine and it will go through iterations and iterations of different models to give you the most accurate model. Once you have that model, you can then deploy that down to the edge using IoT Edge, so that that machine learning model is being used or inferenced on the edge as opposed to in the cloud, having to bring that data back. So that's totally up to you. You've got those options. Just to finish, I've embedded some links here. The Croke Park Innovation Case Study is one I personally worked on, and it's a little bit old. It's a couple of years old, but still good. There's a free learning path that we've made available for IoT School, a couple of reference architectures, and then solution accelerators, which are really powerful. They just allow you to spin up a resource group in Azure with all of the different components that you'll need. You can then customize them, edit them, remove pieces, add pieces, and do what you like with it. But some really good resources in there. So, whistle-stop tour of IoT capability and some of the learnings, and I look forward to some of the questions later on. Thank you.
Niall, thank you for packing so much into that. And as an architect, it's good to see a good consideration of non-functional requirements as you're choosing as your infrastructure components.